Hey, Jeannie.
Yeah, Brew.
Philip is back.
Hey, Philip.
Hi.
Hi, glad to be back.
It's really good to see you. So, in case our audience doesn't already know, Philip Eash-Gates is a principal at Synapse. And Philip is an engineer and policy professional specializing in carbon and energy policy, strategic electrification, energy efficiency, industrial sector decarbonization, energy supply technologies, building performance standards, state and municipal energy planning, and health and environmental impact assessment for more than 15 years. You manage Synapse's consulting practice for carbon and energy policy with responsibility for developing methods, tools, and regulatory analysis to enable consistent evaluation and recommendations across the practice.
How does he have time for all that?
I stay busy, but it's all good stuff. Hard to avoid diving in on new topic areas as they come up because we're doing so many great things.
Well, it's super interesting, and we rarely get a chance to slow down and look at the details of what you've been up to. So I'm really excited that you're here with us today. Do you want to just introduce what we're talking about today?
Sure. So in 2023, Synapse completed a project that I led with some great colleagues on industrial emissions. And it's the first of a kind study of core heavy industries that are responsible for a disproportionate share of US emissions. And we do a real deep dive into studying those four types of facilities, and they're iron and steel, aluminum, cement, and metallurgical coke, or met coke, which is used in the steelmaking process. And so the study does a good job of pulling together all the publicly available data on these facilities so we can begin to kind of open up what's often thought of as a black box for the industrial sector and begin to think about how to decarbonize it and how to improve health and environmental quality in our neighborhoods, our fence line communities that surround these facilities. So really exciting project. And then this month, my colleague Jack Smith and I got to travel to speak with congressional staffers on the Hill to talk about the study and to help give them the data that they need to write good legislation on this. And some congressional staffers are already using our database pretty extensively. They read through our report. They had really great questions and have been building some legislative language around the work that we've done. So it was a really great opportunity, and we're excited to see it out in the world making a real impact.
That's always great. Who are the clients for this, and what are they up to with these tools?
The client is Sierra Club, and they have a living economy team that focuses on industrial sector transformation. They do a lot in partnership with Blue Green Alliance, thinking about how blue labor and green environmental sustainability comes together in the industrial sector. They are using this tool for their education and outreach with their state and local chapters, especially in those communities that have large industrial facilities. And they're also using it in their conversations with policymakers on how to inform good policymaking for the industrial sector. In particular, they've been working a lot with the White House on a federal buy clean policy that's focused on how to get the federal government to procure low carbon intensity materials, because the federal government, as you might expect, is a really large purchaser of iron and steel and cement for all the roads and buildings and things that it funds.
So we got this great tool and people are using it for important things, and it's not possible for just anybody to use this tool, right?
Of course it is, Bruce. That was the whole intent. We made it a pretty simple and straightforward interactive website.
But it's expensive, right? Is it expensive?
No. In fact, it's free to the public, and that's the goal is to get out of this space of confidential business information that's hard to parse. And there's dozens of EPA databases with all of the toxic pollutants and greenhouse gas emissions and sort of all the other information that we pull together into one place for the first time, and it's available on the website. And we also have a master database that you can download and just rifle through the information. Hundreds of columns of data and hundreds of rows of individual facilities. So you can drill down to what's happening in my community and how much lead is being put out by this particular cement plant, how much particulate matter is coming from this steel mill, that sort of thing.
So all that data, this tool is available for just any random energy nerd to use for free?
Absolutely.
So if I'm a procurement manager for a small municipality somewhere, could I figure out the carbon intensity of comparing between two different...
Your local cement?
Well, whatever we're buying, yeah. How would that happen?
So I'm based in San Antonio, Texas, and San Antonio has 3 large cement facilities. And if I were working with the city of San Antonio, I could go into the database and look at the three of them. Cement is really heavy, and so you don't want to ship it long distance because that adds to the carbon emissions intensity. So I could look among the three plants that are in the city, and I could identify which of them had the lowest emissions intensity, and I could contact them directly and preferentially procure from them. It gives them an economic incentive to keep doing the good, cleaner work that they do. And so it's a real economic opportunity, we think, for the leaders to become examples for the laggards.
I feel like Philip can show us a map.
That would be so fun if he could.
We love maps.
I would be delighted to.
How many tons of emissions are we talking about?
Across all of industry in the United States, it's 26% in 2021 of the total national emissions is associated with the industrial sector. If you include what we call scope 2 emissions, the emissions associated with the electricity used in these industrial facilities. So it's a big piece of the pie. And these four industries that we look into, iron and steel, metallurgical coke, cement, and aluminum, they are the top emitters. And aluminum is maybe not as large in magnitude, but it's one of the most emissions intensive materials to produce because it uses just a massive amount of electricity. And it also has a really carbon intensive or greenhouse gas emissions intensive production process. So we're talking about a really big piece of the pie here. And this tool kind of lets you look broadly across all the facilities. You can click on a particular industry that you might be interested in, and it will highlight just those ones. Here we're talking aluminum, and switching over to cement, for example. And you can use this drop-down bar to identify which metric you're most interested in. So let's talk about scope 1 and scope 2 emissions intensity. So as I was saying just a minute ago, aluminum is really emissions intensive, and that's why you see that the orange circles here are the largest. So the diameter of the point is proportional to the emissions intensity, meaning how many greenhouse gas emissions are emitted per ton of material that you produce. So this tool allows you to kind of get a glimpse broadly of what's happening in the US, and you can mouse over any individual facility and get detailed information on the name of the facility, the type of equipment that it has, and the process that it uses, the end products, where it's located, its parent company, the amount of materials produced at the facility each year, jobs, emissions, the whole gamut. Maybe you're interested in your particular community and you want to zoom in, and the tool allows you to do that. And you can kind of see the geographic clustering of different industries. Metallurgical coke is often located close to iron and steel because it's an input into the metal and steel making process, for example.
Wow, cool. Do you have a favorite rolled flat products facility, or someone who's particularly clean as a good example, or particularly dirty?
Great question. Let's jump over to the next tab. And here you see a figure or a series of figures where we identify within a certain class of facilities how emissions intensive they are and kind of plot them against each other. And so you were asking about electric arc furnace flat products, I believe. So we can zoom in on those ones, and you can see this facility up here is the dirtiest in the United States. And this facility down here is the cleanest. It has the fewest emissions per ton of steel produced. And so I would say maybe this one's my favorite because it's the cleanest. But we've overlaid on top of this plot some environmental justice metrics. So you see here the legend on the right is colored based on the fraction of households in the surrounding community that are people of color or minority households. And so it turns out that this dirtiest facility in the US also has some of the highest rate of minority households in the fence line community surrounding it. So maybe that's a cause for concern, given that it's not only polluting a lot of greenhouse gas emissions, but it's also in a particularly socioeconomically disadvantaged community.
Well, it seems like they have a lot of room for improvement.
Definitely. And that's where the buy clean policy, the preferential procurement comes in, or other policy tools. Some of our listeners might have heard of the carbon border adjustment mechanism that was passed in the European Union. There's been 3 bills in the US that have been proposed to do the same thing. And it would basically put a tax on the good based on its emissions intensity. And between that type of economic incentive for imports and also the preferential procurement from government, you can really start to incentivize these lower emissions intensity facilities and hopefully encourage the poor performers to catch up.
Cool. It looks like you have more graphs hiding here.
Yeah, so we have scope 1 and scope 2 emissions intensity. And then here there's like a dozen or so tabs where we overlay different environmental justice metrics on top of the emissions intensity. So we have socioeconomic ones, persons of color, income, education, language, unemployment. And then we have a range of environmental ones, cancer risk, respiratory toxics, diesel particulate, so on and so forth. And so you can click on any of those tabs and see the detail there. Those are the sub-tabs, but our next major category is plant emissions curves. And it sort of stacks up all of the plants within a given industry against one another. So you can see, in this case, the height is proportional to the emissions intensity, and the width is proportional to the amount of product that's produced in the facility. So the covered area is the actual total amount of emissions. And you can mouse over and see what are the scope 1 emissions intensity here in gray, what are the scope 2. And you see here, aluminum has really high scope 2 emissions intensity because it uses so much electricity, as we've discussed. So there's only 7, well, today actually only 5 aluminum facilities in the US, so the bars are pretty wide. But here, cement facilities, there's about 100 of them in the US, and so you see the varying widths of the bars. It's a good way to kind of identify, again, the leaders and the laggards and figure out where the greatest opportunity is to decarbonize heavy industry. And then maybe I'll just quickly jump to the last tab. The last tab is our environmental justice analysis. Sort of similar to the emissions intensity, we plot a range of environmental justice indicators for each group of facilities. And we show here that the solid horizontal bar is the national average, in this case for people of color in the US. And then we plot the individual facilities as individual dots and show representative information for the fence line community in a 3-mile buffer around the facility. And the dotted horizontal line is the industry average. So you see in this case, the fence line community in aluminum facilities tends to be more white than the US as a whole, whereas these integrated steel mills, the blast furnace and basic oxygen furnace facilities, tend to be more minority communities. Across the board, we see that all of these industries tend to be located in communities that are poorer than the US on average. So that's why this dotted horizontal bar is higher in the graph than the solid one. So that's the EJ figures, and there's, again, a whole host of them that the user can peruse and hover over and identify leaders and laggards and cause for concern.
Take that one in the middle, right? This steel. How would you read that in terms of the solid line, the dashed line, and the scatter of dots? Like, what does that tell us?
Right. So that tells us the facilities that have the highest minority population surrounding them are up here, and they're on the order of like 90% minorities in the surrounding community. So this Cleveland Cliffs facility is a good example of one. Whereas on the lower end, we see that this facility in Middletown, Ohio, is more like 20% minority. In the US, where on average, something like 40% of households are minority head of household. But these integrated steel mills, on average, are more like 60% minority communities. And they also happen to be some of the dirtiest facilities, or the most heavily polluting ones. So they're having a disproportionate impact on minority communities.
Can we go back to the previous set of slides? If you were talking about scope 1 and scope 2 and how aluminum really balloons out when you consider scope 2, is that impacts from whatever's in the electricity grid? And so in your analysis, you did specific like marginal emissions for that location. Okay. And yeah, do you want to talk about that?
Sure. Yeah. For each facility, we identified the appropriate marginal emissions rate for the grid based on where the facility is located. And for some facilities, we actually were able to find information on their renewable energy supply, their specific supply mix. The worst performer among all the facilities, this Alcoa facility, actually happens to have a coal plant on site. So they are producing 100% of their electricity using coal, and then they're selling a lot of it back to the grid, but we don't count that portion. We're just counting the amount that goes directly into producing the aluminum. So it's a really dirty facility for that specific reason. And different facilities around the country, like this one, the one in New York, this one in Washington, which has since shut down, was almost 100% on hydropower. So it's kind of unfortunate to lose a facility that's a cleaner producer. You see that it's got relatively lower emissions.
Interesting. I guess my question is, if not that a person would be choosing between an aluminum smelter and a met coke facility, but it seems like because of the energy intensity that the aluminum, the emissions are much more dispersed, except for in that case of the Alcoa plant with the coal plant right at the site. But are the local emissions less impactful than some of the other industries?
Meaning the toxic pollutants?
I guess that's mainly what I'm thinking about.
So we see the spread of greenhouse gas emissions intensity, and you're asking what's the spread of toxic pollutant emissions intensity?
And particulates and things that are affecting things other than climate change.
Yeah, it's a great question, and it's something that we did look into. We actually pulled what's called a RESI score. That's RSEI, and it's a risk screening metric that's put together by the EPA, and it considers the specific pollutants that are released by a given facility, the toxicity of each of those pollutants, and also the concentration of people surrounding the facility. So it's like the human health impact score, and we rank all of the facilities that we look at on that RESI score index. And that's something that isn't shown here in the interactive web tool, but you can find in the master database. And there are some facilities that really stand out as having major adverse health impacts for the community around them. And then there's some that are quite clean and have a very low health impact. So folks that care about not only climate, but about the vulnerable communities surrounding these facilities can go and preferentially procure from those that have the lowest impact.
That's so great that this is available. My co-host is super in demand, so he had to split, but this has just been great. I'm so encouraged to know that Synapse is doing work on this topic. It's a little bit beyond. I mean, you've really pushed the margins of what we can do here at Synapse, and to make a tool that is useful in this way to so many people is really encouraging. And thanks to Sierra Club for supporting it, and to you and the team for making it seem manageable and usable. I'm really excited to see how it goes.
Thanks so much, Jeannie. Yeah, I'm glad to hear that you think it is a useful tool, and we're excited to see how it's picked up by policymakers and community organizers and environmentalists around the country.
Excellent. It's been great seeing you.
Really nice connecting, Jeannie. Thanks. Take care.
Thank you so much. Bye, Philip.
Bye.